This FedGov Today program is sponsored by Maximus. On this edition of FedGov Today, one of the Army's cutting-edge programs follows age-old advice. Keep it simple, soldier.
The overarching goal was to make it easy for the operator to use and to minimize the workload. Because otherwise, if the operators don't want it, what are we doing?
The Army's Dr. Shane Thompson on FedGov Today in just a moment. Uniting program strategy, advanced technology, process, and execution for a more efficient government. That's Maximus. Every program, every service, every time. That's innovation forward. Learn more at maximus.com/federal. The Army's evolving a program that will let soldiers use multiple missiles to engage multiple targets. The service is already getting feedback on the Multiple Simultaneous Engagement Technologies, or MSET, suite of applications from soldiers in the field. Lieutenant Colonel Jim Lawson is product manager for aviation rockets and small guided munitions at the Army's Tactical Aviation and Ground Munitions Project Office. Dr. Shane Thompson is program manager for MSET at the Army's Development Command Aviation and Missile Center. Gentlemen, welcome. Thanks for joining me. Shane, I'll start with you. Thanks for being on the program today. What is MSET and what does it allow soldiers to do? Welcome.
So thank you very much, sir. So in very simple terms, MSET is a suite of applications designed to enable a single operator to launch and monitor multiple weapons on either a single high-value target or multiple dispersed targets. And we have two component applications that reside on the missile themselves. There's that thing that finds the target and tracks it. That's called Precision Target Acquisition Software, or PTAS, developed by my team here at the Aviation and Missile Center. And we've coupled that with the application that coordinates time of arrival of assets amongst the multiple missiles. That was developed by Johns Hopkins University Applied Physics Lab under their Autonomy Toolkit program. So we basically combined those two technologies together, tied them in with the user interface that allows a user to monitor an engagement, but the user can then at any time step in and take control of the engagement for regret avoidance, retasking, or whatever the situation may mandate at the moment. So that's what MSET does. And again, in very simple terms, what it's allowing is a single soldier to mass fires onto threat systems.
Jim, welcome. Thanks for being on the program. What does that look like for the person in uniform that is actually going to put those missiles on targets?
Yeah, Francis, thanks for having us today to talk about this program. So what that really brings, the novel capability that brings to the warfighter out there actually employing this munition, like Dr. Thompson said, is a one-to-many control in a much smaller scale organization to build a mass fires onto a target or multiple targets simultaneously. So that's a pretty novel capability that has not existed, and not to mention the range is going on. So we're taking that MSET technology and putting it on our program called Long Range Precision Munition, which is the lethal launched effects variant that the Army is developing.
Jim, what was the demand signal that caused you and your colleagues and team to start to want to develop this capability?
So in reference to long-range precision munition as the program that is hosting now the MSET S&T program that was developed with Dr. Thompson's team, in summer 2024, the Army released its Launched Effects Abbreviated Capabilities Development Document, which is part of the new streamlined acquisition process that was developed over the past several years. And that really triggered the program. So this program, Long-Range Precision Munition, started mid-2024. And we were able to get essentially a turbo boost in advancing the program by taking all of the S&T work that the Aviation Missile Center did under Dr. Thompson and incorporating it into our program.
Shane, you talked about the PTAS software and the collaboration with JHU. What was involved in that, and how did you determine what you were going to do and what Johns Hopkins was going to do to get the product that you have now?
Okay, the latter part of that's simple. We knew that we had two major requirements to achieve putting multiple missiles simultaneously on targets. We had to find the thing and track it, and then we had to coordinate the assets together. So the delineation of the work was pretty clear. The PTAS part of it was a product that we had in-house and developed under another S&T program that transitioned into MSET, specifically was sought after for this program because of the way the technology that it uses emphasizes precision on a very specific target. It has a very low probability of failure on anything else. It will go after that thing that you tell it to go after. But in order to make that act in a collaborative way to put simultaneous multiple groups of missiles onto a target, we needed that piece to be able to coordinate the mission planning and execution between the multiple missiles. When I first started the MSET program, it was really my first introduction to autonomy in general in terms of the technology area. So I had to pound the pavement, go around to a variety of different providers, mostly university-associated research labs like Johns Hopkins. There were a couple of others. And through a process of elimination, I basically determined who had the best capability to offer, who was most mature in their development, who had touched the most number of platforms that had experience with all the pitfalls that come in integration, and ultimately landed on them through a decision process to get to them. But from there, the delineation of work was straightforward. Basically, my PTAS team handled all of the image processing to acquire and track the target. Johns Hopkins handled everything else other than that: the mission planning, the setup, the route planning and execution, and the coordinated time of arrival of assets. But they've been a great partner to work with. There's a bunch of brilliant engineers and scientists on their team, and their contribution to MSET has been invaluable.
As somebody who grew up near Baltimore, I take that comment very proudly. As that collaboration evolved, what developed differently than what you expected when you set it up at the beginning, whether it's the work that you did, they did, or how you integrated it together? What turned out differently or came out differently than you expected it to at the beginning, Shane?
I'm afraid you told me we were limited to 15 minutes. In any research and development project, I can't think of anything that turns out the way that you envisioned it in the beginning. It all evolved over time. I wouldn't say that anything grossly delineated from what we had originally envisioned. It was more the minutia. The devil's always in the details. When you start taking these applications and integrating onto a specific platform, you get into all kinds of pitfalls on making sure you're sending commands at exactly the right time, the latency between the data that's floating around the system. I mean, it was very, very low level details. But honestly, from a top level perspective, we started very much from a let's crawl, walk, run, so that oftentimes R&D programs want to start off in a sprint and go after the absolute sexiest end case possible. And oftentimes people run into walls really quick that are hard to come over. We started from very basic concepts and then slowly built on top of those as we went. So because it was more of an evolutionary development mindset like that, I wouldn't say that things changed that much. Rather, they evolved as we learned more things over time.
Jim, there's a couple pieces about this that I read online that I think are really interesting. I read, the system is operated through the MSET user interface within the Android Tactical Assault Kit, ensuring a familiar and effective experience for the soldier. Was that something that you started out as a desired outcome? You going into this with a desired outcome, that it was easy for the soldier in the field to use the moment that person put hands on it? Or was that something that developed over time as you got feedback from soldiers in the field, whether they were actually using it or whether you were just floating the idea about what you were going to do to them?
So I'm gonna defer the detailed response of that decision to Shane, because that's they made that decision early on in the MSET program to use that. But I can tell you that feedback we received validates however they came to that decision, because that is the native environment that you're seeing operational units go to. All these soldiers are kitted out with touchscreen user interfaces. And so the decision to go after a ATAC native interface or TAC native interface is playing out really well for the long range precision munition program, thanks to what MSET did.
Yeah, and just to follow on to that, I mean, again, it was really experience with other programs. I mean, I've worked programs before where the implementation and the workload on the soldier was a high burden. And so our goal coming in the door was to make sure to make this the simplest possible interface for the operator and to minimize his workload. In fact, workload minimization was the overarching development concept in MSET. As part of that, a lead into MSET, there was a program that preceded MSET done here at the Aviation Missile Center, where they used some first-person video-based attack drones, where basically the soldiers on the stick the entire time, steering it in, finding the target, drawing a box around it, keeping the track on the target the whole way through. So we started this initial demo with that to basically measure what the operator workload was. And what we found was that when in doing multiple missiles, it first burdened the operator too much to try to do them simultaneously. So he had to go sequentially. And then with all those interactions required, it looked like we were getting a median of around 18 to 20 interactions per missile per engagement. So that was our measurement. We wanted to reduce that workload below that. And by the end of the program, we had it down to, in most of our engagements, 0. After mission initiation, the operator sits and sips coffee while it goes on. And unless something comes up that the operator needs to change, they can just watch the engagement happen. But that was the overarching goal, was to make it easy for the operator to use and to minimize the workload. Because otherwise, if the operators don't want it, what are we doing? It's we have to make technology accessible to the operators who are going to use it, or otherwise it'll sit on a shelf and they'll never pull it off.
We talked a little bit before we started recording about a test that you all both attended at Fort Irwin in California. What was your takeaway from that in seeing this in the field and seeing people hands-on with this? Jim?
Yeah, so that was a really great event. And, so that event was run by a test organization out of Fort Eustis, funded by the Utility Helicopter Project Office. And it was really to show that you can fire launched effects from a Black Hawk helicopter safely. So that was the main objective of that test. But of course, we wanted to maximize the test event, so we were really trying to stretch the systems to do everything that they're supposed to do and to get as much data as we could collect from that. So I think anybody who has done a weapons program or a weapons integration program onto a aviation asset understands that's inherently challenging. You're experiencing environments that are not easy to replicate. And on top of that, you don't have a lot of real estate on the helicopter to play with to make sure your system can function properly. So credit to the Utility Helicopter Project Office and the folks out of Fort Eustis for designing a system that allowed the safe launch of the long-range precision missions out there. But it was great. We actually got to shoot them at about 110 degrees, dead middle of the day, high temperature. We actually did some pretty cool stuff with image capture and transfer to the LRPM that I probably can't dive into too much detail here on. But we were able to exercise the system pretty thoroughly, and it's going to pay dividends to us as we go into our formal testing and qualification program now.
Jim, of all of the things about this that I found fascinating, though, this is the most interesting to me as somebody that sits in Washington and hears about the issues that the military has in getting programs out of S&T and into development. You said recently this is a successful S&T transition that didn't fall into the valley of death where S&T all too often finds itself. What do you think the secret to that was that other organizations in the department could learn to avoid the same problems that you allude to in that comment?
Yeah, so every S&T program inherently has a transition partner built in at some point to it. So as the smart folks like Shane are coming up with these ideas to run through their S&T leadership channels to get approvals and fundings, they have to show a pipeline, a pathway to life after S&T, and correct me, step in where you think I'm wrong here, Shane, but I think that has done a lot, right? Every program has to go through that to show, hey, what's the usefulness of this project after the project's completion? I would really just say the stars aligned for us. We had funding lined up. We intentionally went after trying to incorporate that S&T program into a actual program of record. So I would say that why it worked out here is maybe not the advice I would give. Why it worked out here is because they developed a quality product that had direct applications to a requirements document that came out, and we were able to successfully get resourcing and leadership approval to proceed. But I would say, we just need to continue to put scrutiny on the program offices who are the transition partners. They really, when they commit, they need to not just sign a memorandum. They need to look and say, yes, I can absolutely use this. Otherwise, why are we doing it? Certain S&T programs really need to be done just to expand the boundaries. But I'd say for a majority of them, they need to have a very hard tie-in with a high likelihood of success to enter into a program of record. And I wouldn't put that on the S&T community as much. I put that on the receiving program offices who are going to take that S&T transition.
Shane, anything you want to add to that about that transition?
Yeah, I do. Because he was right. So much of this was fortuitous, stars aligning, but there was some legwork that was put in before that, even proceeding before Lieutenant Colonel Lawson joined the LRPM team. LRPM was an emerging requirement, task force type level of a branch of the project office for several years. And we never hesitated to take them up on an opportunity to get together and talk, to update them on how our tech was evolving, what kind of missions we were designing towards, and to get their feedback, to make sure that we were developing a product that had a home at the end. Because much like I was talking about earlier with making it something that the users would want, well, if the project doesn't want it, it's really going nowhere. So that was very important to us to get that feedback as we went along. And like Jim just said a minute ago, that I credit a lot to the people at TAGM Project Office who interacted with us. They didn't just sign the memo and assume and hope for the best at that point. They reached out to us. They interacted. It was those kinds of things that are so simple to do, but unfortunately escape some people, I think, but were so invaluable to aid us in the development.
And if I may add to that, one more thought that kind of dovetails with what you're saying, Shane, is a lot of people execute their programs in silos. Hey, I got my set of test events over here. I have 10 test events over here that I'm going to do. And on the back end, you can have something. Hey, I have my 10 over here that I'm going to do, and we'll talk afterwards. Something we've done very deliberately with not only Shane and his team as they're still continuing to close out their S&T program. We're still leveraging residual work they're doing to benefit the long-range precision mission program record. We're also doing that with the Utility Helicopter Project Office. The event last week that you brought up earlier is another key example. We heard that they're doing a launched effects test, and we said, hey, well, I have a launched effects program. Let's cross our lines here, merge, and get the synergy. I know that's a buzzword, but get synergy between our programs here, maximized. So we got to stop looking at just our programs in isolation and really look across and tie in, especially in this Army where we want to go fast. We can't do things sequentially and in serial anymore. We have to do them in parallel and intertwined. That does involve bringing more variables to a test event, which isn't necessarily super conducive for engineering, analysis post event. But it's how you have to do it to go fast. You have to take those big swings so you can take bigger steps forward, so we can move faster and meet the needs of the warfighter at greater speed.
Lieutenant Colonel Lawson, Dr. Thompson, great to have both of you on the program today. Thanks for your time. I really appreciate it.
Yeah, thank you.
Thank you, sir. Enjoyed it.
You can read more about the MSET program and how it beat the Valley of Death on today's show page at fedgovtoday.com. Implementation's underway at the Defense Health Agency for its data strategy for fiscal years 2026 to 2030. The agency says it's aligning its efforts to a department-wide call to become AI-first organizations. Dr. Jesus Caban, the Chief Data and Analytics Officer at DHA, will tell you about it on this week's FedGov Today TV. The show debuts this Sunday morning at 10 a.m. on ABC7 in Washington and on the FedGov Today YouTube channel. It's on all weekend long on the American Forces Network around the world. If you miss the debut this weekend, you can subscribe to the FedGov Today YouTube channel so you never miss FedGov Today TV. The next FedGov Today podcast comes next Tuesday. I'm Francis Rose. I'll talk to you then. Thanks for listening.